Hey, this is the 10th installment of Advanced J1939. Looking at some actual real data taken from the field. This is actually a combine where there are many controllers on the CAN bus. If I zoom in on this data and I take a look at one of the first bits here, the starter frame bit, and I look at the width of this bit, we'll just take a look at it here and see what it is. We can see the starter frame. We know that that's supposed to be 1 bit. We can see that it's about 4 microseconds. If I go over to my calculator and I put this in standard, so we'll do 0.000004, and we take the reciprocal of that, it tells us it's 250,000. So this is a 250K CAN bus. So pretty well loaded for a 250K CAN bus. But nonetheless, we'll take a look at some of the data and what some of the data means in this. What I can't do is tell you what each piece of data means in this. There's a couple of reasons. Number one, it is SAE, the Society of Automotive Engineers. The database, that data is something that they protect. It's not something that I could give you. You can purchase the data from SAE. It's extremely expensive. It's not something that most people do. Anyways, and truthfully, this isn't something you really have to do. It's something that lets you see how this works. Helps with the theory of operation. I could give you some standard messages which are out on the internet, which are readily available. But what I can't do is tell you what every message means. The other reason I can't do that is some of these messages are what are called proprietary. So the manufacturer of the equipment, SAE allots ranges of parameters where they can put their own information in, and that information, it means nothing to you. You look at it, it's basically meaningless because you don't have the keys to be able to determine what it means. It's as I said, it can be aggravating if you wanted to get into this and find out what it meant, what more of this meant. You are pretty much limited, I guess, because of some of the ownership of who actually owns this. The data that's behind this. But taking a look at this, we'll take a look at a couple of these, and there is a few things that we can do. If I look at this as we determine this 250K CAN bus, I have the priority of this particular message as it comes in has a priority of 6 in hexadecimal. Next is something called the parameter group number. Depending on the type of message, this gets into a lot of detail that I probably can't cover in this course. There are basically 2 types of messages. I'll say there are those which are broadcasted and they are sent out periodically. So once every 10 seconds, once every 1 second, once every 10 milliseconds. These messages are sent out, and that's one type of message, and they're a broadcast message. Oftentimes those are these parameter group number messages, things such as groups of information like temperatures, pressures, speeds. These are all put into a group, and we'll show a little bit of that. The other type of message is one where it's requested by some controller. So the thing you're familiar with is a service tool or a scan tool. If I hook up to the controller and I want to ask a specific controller, what fault codes do you have? For fault codes typically such as stored fault codes and snapshot or freeze frame information, that would be stuff that you have to request. We're not going to occupy and send this stuff on the data link continually. So those are request messages. So I know I would get, if people who might watch this who have a great understanding of it, I'm just going to say for now, we're going to call this first bit of this, just like Pico does, as the parameter group number, or the PGN. So I'm not going to get into a lot of the other detail of this. We're going to try to keep this simple enough to be able to hopefully not lose everybody. So looking at this parameter group number, that's the next thing that is broadcast. And behind that then, the next piece is something called the source address. So let's take a look at what the source address is. Fortunately, one of the things I can show you, this is from the isobus.net website. If we look back on this, on Pico, it says that the source address of this message, who's sending it, which controller is sending this message, that source address is shown as a value of 0. Well, that's in hex. We could, of course, put 0 in hex, and if we want to put this in decimal to put it into this converter, then that one's easy. It's a 0. So if we come over here and take a look, this is, of course, my favorite controller. This is the engine, so number one engine. Some machines may have two engines on them. If they do, then the second engine would be given a source address of 1. Transmission is another one that's very familiar. Anybody who looks at CAN data, typically the first transmission, whatever type it has a source address of 3 in decimal. And so this is the data that's shown in the picoscope here that we can see. This is the next piece, this source address. So that's pretty cool. And then behind that, there's some data. Well, let's find a message. I've actually got one where I can give you, this is a very common message. We're going to look at parameter group number in decimal 65262. And this is an engine temperature. And this is engine temperature message. So the hex value of this is FEEE. So let's take a look and see if that message is here. One of the cool things that I learned how to use on this, it's pretty cool. Let's put in the PGN contains, and we're going to enter that value, FEEE. And because I have everything set to hexadecimal, I have to use hex on this, right? So here we can see we've got message FEEE. Let's just take a look and see FEEE. So as you might expect, because this is engine temperature, the controller which is broadcasting this PGN, FEEE, which has a priority of 6, the controller which is broadcasting that is, surprise, the engine controller, right? It's engine temperature. Who else is going to tell you what engine temperature is? I don't think I want to get engine temperature from the transmission controller or the instrument cluster or any of these others. They definitely might want to know what the engine temperature PGN is, this parameter group number, specific values that are in that. But the engine is the one who's going to tell you what this information is. In this case, just happens to be this PGN that we have access to. There are many of these PGNs, and as I said, I can't give you that information or provide you that information. You have to purchase it from SAE. So looking at a little more of what's in this message, this parameter group number, or PGN. So contained within PGN FEEE, there are, in this case, 1, 2, 3, 4, 5, 6 SPNs, which are suspect parameter number. I have no idea why SAE and others refer to this as suspect. I really don't know. I've never gotten a great explanation. Please, if somebody knows, tell me why that we refer to this as suspect. I know what it is. I guess I don't need to suspect it. But anyways, it's something that's always kind of bothered me. I've never got a great explanation. Please, if somebody knows the real reason, let me know. Put it in the comments. So looking at what SPN are, there is a numbers that are assigned to them. I'm not going to worry so much about those, but we can see that engine coolant temperature, of course, coming a message, which is engine temperature. That's one thing that's there. Fuel temperature, typically that's an input on a diesel engine to the engine controller. We want to know what the fuel temperature is. It tells us what the density of the fuel is, helps us with that. There's other specific things. We also want to make sure that the fuel's not too hot, right? Where we reach a point where we might need a derate because the fuel is too hot. Lubricity issues due to that. So engine oil temperature is another message. These are other inputs. May be applicable: turbocharger oil temperature, engine intercooler temperature, and engine intercooler thermostat opening. Some of these are used, some of them are not. And so looking at this message, we're going to go back to it. We're going to concentrate right now on engine coolant temperature and fuel temperature. Let's see what those parameters have a value of. So looking at this message from the scope, it says byte 1 is engine coolant temperature. So if I look at the data here that is contained in byte 1, so byte 1 of the data would be after this PGN and something called the DLC, which is the data link in this, or the length of the data. In this case, it's 8 bytes. So this first byte of data, which is 8 bits, has a value of 47. So does that mean that engine coolant temperature is 47 degrees? Okay, a couple of questions. Is that Fahrenheit? Is that Celsius? How do I do a negative number then? That seems kind of odd. If it's below that, how would I show that? I mean, I Curious, how would I put a negative number in here? Well, to do this, we need to know a little more information in order to calculate this. I need to know first off about this SPN 110. You can see here it is. It is 1 byte in length, and it's that first byte. So it's byte number 1. It's 1 byte in length. The resolution is 1 degree Celsius per bit. So the question is, how many bits are there here? So if I look at this, it's an 8-byte message, right? It's this message there, that 1 byte has 8 bits in it. But of those 8 bits, how many of those have we used? And so let's take a look at this. We're going to have to take this and let's put this from hexadecimal to decimal. So if I put a value in of 47, the first thing we've got to do, right? That tells us that I've used 71 bits. So 71 bits of this have been used out of the possible of whatever it could hold of its max. So 71 bits. So 71, does that tell me that my engine coolant temperature is 71 degrees C then? Okay, great, got it. However, I do need to have something called the offset. This is how we're able to put a negative number in. So if this had a value of 0, I would take whatever that is, I would multiply it by, or I'd know that it's 0 degrees Celsius per bit, so 0 offset minus 40. That would tell me that it's minus 40, which is really cold. So I've got to take the offset from this. So I've got to remove this offset value from it. So let's subtract. And so we got to go to decimal here, and let's take minus 40 from it. And that gives us a value of 31. So is that my engine coolant temperature then? Do I have an engine coolant temperature of 31 degrees Celsius? The answer is yes. In this particular engine, it had ran a little bit. I recall this is, it is 31 degrees Celsius. If you want to convert that to Fahrenheit, the rule of thumb, double it at 32, okay? It's either that or you can use the data, or the temperature conversion. So let's just go ahead and do that. So if I say that this is in Celsius, let's say in Celsius, this is, put this in Fahrenheit. And what did we say it was? We said it was 31. That tells me it's 87.8. When I say double it, add 32, that's pretty close, but close enough for engineers. Go back to my programming calculator and back to the data. So this is data. This is how this is done. We can see that this message, the big pieces of information, here's that parameter group number, FEEE. The source address is 0. In this case, we could go over here to this website and we could put this in the ISO and we could see that engine is 0. And then we're looking at that. We know this is the PGN. We look at what byte number 1 is, and byte number 1 is engine coolant temperature, has SPN of 110. What we have to do first, let's take that, let's convert that to decimal so that we know how many bits that is, how many bits there are. We took that and converted the 47 into decimal, from hex into decimal, subtracted minus 40 from that, and that told us what the engine coolant temperature was. We'll take a look at a couple of other parameters that are here within, and some of these we probably won't be able to see what it is, but we can at least see what the source address is. So looking at this piece of data, as I go down through it, I have a parameter, I have a priority of 3. So this is a more important message than what the engine temperature message was. And contained within it is PGN F3. What that is, I don't know. It is one that is that I'm not real familiar with. This could be one that's proprietary, but regardless, it doesn't matter, right? I've got the devices on the data link know what to do with this. And if it's something for the service tool, it knows how to take it and convert it. But let's take a look at this source address. This is something that is important. What source addresses are there on the bus? So this is a value of 17. So if I come over to this table, I can't just put a value of 17 in here and see who is 17. It says that's cruise control. What I have to do is I have to take that value in hex. Let's clear this out. And 17 has a value in decimal of 23, and 23 is instrument cluster number one. So typically that's the display. That's something with the vehicle display. So there's some information that is being broadcast or is being communicated by that instrument cluster. We can take a look at another one here. We have a source address on this one of F3. Of course, that is a hexadecimal value, so let's clear this out. Let's put a value of F3 in, and we can see that in decimal, that is 243. So let's take a look at who is number 243. And I think what you're going to find here is 243 is something here. I need a little more information about it. This could either be battery pack monitor number 1. It could be product loss monitoring, engine monitor 3, marine display 3. What this says is I need to also know what that industry group is. So this is another piece of this. This is where you're going to find it's like this information is not readily available to you out there, unfortunately, unless you spend several $1,000s to buy the SAE specifications. Not something I would definitely recommend. Something I can recommend if this information, this kind of stuff is very, if you find this very interesting, this is an outstanding text. It is written more for, I would say, for engineers. But nonetheless, this is a very good text. It's relatively inexpensive. It's something you can get as a PDF, as a download. This author does a fantastic job with this book. There's another one that he has written on CAN, which I would recommend to go with this. So if you find this interesting, once again, it's not going to give you a lot of the database information. He had one example which he placed in here. Other than that, it's going to help you a little more with some of the theory if you really find this interesting. So next time we'll talk more about data, and then we'll get into at some point here something with failures and determining what failures look like on the scope.